This is the beginning of section 1.2 in our textbook, and the objective of section 1.2 is the evaluation of formulas and solving a formula for a specific letter. It's a very short section, so now there are some general rules for solving an equation, solving a formula for a given letter. And so here is the outline. There are 6 steps, and well, let me just go through those 6 steps. Again, they're pretty straightforward. It's basically what we learned about solving equations in the previous section. So if there are fractions, we multiply both sides of the equation to clear any fractions or decimals. And if there are parentheses, we remove them by using the distributive property. Then we collect like terms on each side if that is applicable. And so maybe we need factoring if there's a variable that is in more than one of the terms. We talk about that when we get there. And then we use the usual rules, the addition principle, and get all the terms with the letter to be solved on one side of the equation and all the other terms on the other side. Again, we collect like terms if that applies, and then we solve for the letter in question using the multiplication principle. Again, we notice that we use the multiplication principle last. So what's a formula? Well, a formula is an equation that represents or models a relationship between 2 or more quantities or variables. For example, the relationship between the perimeter p of a square and the length side length s simply means if we have a square here, the side length s, so for a square they're all the same, then the perimeter is simply equal to 4 times s, and the area is equal to s squared. And there are a lot of formulas you're familiar with. Maybe the area of a circle with radius r. This is supposed to be a circle, and here's the radius r. Then we know that the area is equal to pi times r squared, where pi is a special number. It's an irrational number. More about that later. And we can also compute the circumference, and the circumference of the circle is equal to 2 pi r, or pi times d. So 2 pi times r, or if we use the diameter, it would be pi times d. So here's some basic formulas, and there are a lot more geometric formulas for plane and spatial geometry at the end of the book, if you go in the back. So plane geometry and solid geometry. So these are some formulas that you're supposed to be familiar with. The area of a rectangle, square, we just talked about it, triangle, and some other things you definitely want to look at. Those are the most basic formulas that you're supposed to know. Okay, now there's some other things, some other formulas that the book talks about, and I will go over some of those that are in the book. And there's a body mass index, and that's used to determine whether an individual has a healthy weight corresponding to his or her height. And so body mass index is supposed to be between 18.5 and 24.9. That indicates a normal weight. And but again, don't be too mesmerized by those numbers. The body mass index for men and women is different, and for children and so on. Anyway, it's a rough estimate only anyway. So, but there's a formula for the body mass index. The book uses the letter I. Other people use BMI for body mass index, but it's 703 times W divided by h squared. So that's a body mass index, where the weight is in pounds and the height is in inches. So W, the weight in pounds, and h would be the height in inches. So the charts and tables and all of that models the relationship between height and weight and so on, but this is a formula to compute your body mass index or that of someone else. And so in this formula we can solve for any of the variables. For example, if we wanted to solve this formula for W, solve for W, let's suppose that is what we're supposed to do. Solve the formula for W. Notice we have an h squared in the denominator, so we multiply both sides by h squared. So we have I times h squared equals 703W divided by h squared times h squared. And of course, on the right hand side, the h squareds cancel. And now we have I h squared equals 703W. And remember, 703 is a coefficient of W, so to isolate W, we divide both sides by 703. So 703W divided by 703 equals I h squared divided by 703. So then the 703 cancel on the right hand side. So then we have IH squared, or HI squared, h squared I rather, h squared I divided by 703 equals W. Or it's probably preferable to write W, since that's the variable we are solving for, is h squared I divided by 703. You notice that it's switched from IH squared to h squared I. And again, mathematically, that means the same thing. But this is a preferred way of writing it because it's in alphabetical order. H comes before I. So h squared I would be a better way of writing the formula. So now we solved this formula for W. So here's an example. Suppose we know someone is 6 feet and 1 inch tall and weighs 195 pounds. The question is, what is that person's body mass index? Well, remember, we need to convert the height to inches. So 6 feet is 6 times 12 plus 1 inch would be 73 inches. So therefore, our formula now would read I equals 703, that's the constant that came with the formula, times the W, the weight, is 195, divided by 73 inches squared. And when you calculate this, that turns out to be 25.7, would be that person's body mass index. That's a very simple calculation. Or in another example, we know a person's body mass index is 24.5, and that person's height is 5 feet 8 inches. And the question is, based on that knowledge, what is that person's weight in pounds? So again, we use our formula. I equals 703 W divided by h squared. So here we know what the body mass index is. So we know it's 24.5 equals 703 W divided by h squared. So we need to convert the height into inches. So it would be 5 times 12 would be 5 times 12 plus 8 would be 68 inches. So we square that, 68 inches squared. And so W would then equal 68 squared times 24.5 divided by 703. And when we calculate that, that turns out to be 161 pounds. So W equals 161 pounds for that person. Here's a formula from physics. It's the centrifugal force formula, where m is the force, and m is mass, and v is velocity, and r is the radial distance from the center to the object. And so if we are to solve this formula for m, solve for m, if that's the requirement. So remember, we need to clear the fractions. So that means we need to multiply both sides of the formula of the equation by r, because r is in the denominator. So we multiply on the left side f times r, and on the right side we have mv squared divided by r times r. So on the right side the r's cancel. So we have Fr equals mv squared. So remember, we are solving for m, so therefore we need to divide both sides of the equation by v squared. So Fr divided by v squared equals mv squared divided by v squared. So on the right side, the v squares cancel out, and so we are left with Fr divided by v squared equals m equal to the mass, or m equals Fr or Rf divided by v squared. Let's look at this formula. T equals Q plus Q times V times Y. And we're supposed to solve that one for Q. So we need to rewrite this a little bit to make it more obvious. We write it as Q times 1 plus Q times V times Y. And now we use the reverse of the distributive property. It's called factoring. So we can write this as Q times 1 plus V times Y. And that's all equal to T. Okay. So now remember, we want to isolate Q. That means we need to divide both sides by the expression in parentheses. Both sides. So we divide T by 1 plus V times Y equals Q times 1 plus V times Y divided by 1 plus V times Y. And so on the right side, we can cancel the 1 plus V times Y. That leaves us T, this T equal, T divided by 1 plus Vy being equal to Q, or Q equals T divided by 1 plus V times Y. So you may want to go over that again to understand it properly. There's a similar example in the book, so the more formulas you solve for one of the variables, the more confident you would be as to how to do that. So practice will help you definitely get there. And so I recommend you do all the examples in section 1.2, that you understand each and every one of them, and it'll be pretty simple once you've done a lot of these. So that concludes section 1.2.